Okay, good morning class. Good morning class. So today we're looking at the grade 11 paper that you guys have written, paper 2. And this is the June 2024 in our school. Alright. So the paper was 2.5 hours long and was out of 125 marks. The question paper and memo can be found in the description box below. So we are told that in the diagram, just pull this down here. We are told that in the diagram, A, which is 2 and negative 2 and 2, B, which is negative 4 and negative 6, come inside. C, which is 4 and minus 2, right? And E, which is 6 and Y, are vertices of a quadrilateral having AE being parallel to BC. Okay? The larger parallel, what do we know? Gradients are equal. Okay? No problem. And then we are told that AD is perpendicular to BC. And then we are told that AC is drawn, M, which is x and 2, is the midpoint of BC. So this is the midpoint here, so I'm just going to mark it on the diagram, and as we can see that is already marked 90 there. Okay, perpendicular. So let's go to the first question. The first question says, determine the gradient or calculate the gradient of BC. Calculate the gradient of BC. So BC, the gradient of BC is going to be y2 minus y1 over x2 minus x1. So B's coordinate is negative 4 and negative 6, and C's coordinate is 4 and negative 2. So it's going to be negative 6 minus minus 2 over minus 4 minus 4. Which gives me now negative 4 over negative 8, which is R. The gradient is going to be R. Okay? Number 2, 1.2. If M is the midpoint of EC, determine the value of x and y. So if this is the midpoint, we know that x1 plus x2, which is the endpoints, equals x mid. And then y1 plus y2, the two endpoints, over 2 is equal to the y midpoint. So x1 is going to be, of course, 6 plus 4 over 2 is equal to x, which is the midpoint there. And then y plus negative 2, which is negative 2 over 2, is equal to y mid, which is 2. So naturally that's over 1 across multiply, so that gives me 10 times 1 is 10 is equal to 2x. So x is equal to 5. Okay? And on the other hand, cross multiply here. Y minus 2 is equal to 4, so y is equal to 6. Okay? Just follow and let me know if I make a mistake. Okay? Alright, so what I'm going to do is I'm going to take this off, because whatever we have calculated as well as on the diagram, I'd like to keep the diagram in focus. Okay. 1.3. Question 1.3 says calculate BC, the length of BC. So BC is this length here. So how do we calculate the length? We use distance formula. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. So BC is going to be 4 minus minus 4, which is 4 plus 4 squared, plus negative 2 minus minus 6 squared. Okay, so let's just pull up the calculator in. You do the square root of 8 squared plus 4 squared gives you the root of 80, which is 5 root or 4 root 5. Okay. 1.4, the question says, if it's further given that AE is the root 80, A is the root of 80, which also 4 root 5. To which group of special quadrilaterals does A, B, C, E belong? So we now know so far that opposite sides are, we got one pair of opposite sides parallel and equal. So therefore, this is a parallelogram or a form. Okay. Next question, 1.5, it says determine the equation of AD. 1.5, determine the equation of AD in the form of y is equal to mx plus c. But as you can see here, AD, we only have one point with this line, okay, so we need to grade it as well. So we know there's a relationship that is existing between AD and BC. The product of the two gradients is minus 1. So the gradient of AD times the gradient of BC, which is half, is equal to negative 1, which implies that the gradient of AD is going to be negative 2, which makes sense. Gradients line, the lines lying to the left is a decreasing function. So y is equal to negative 2x plus c. We'll substitute the point that's lying on this graph, which is A, which is negative 2 and 2. There's an x and a y. So 2 is equal to negative 2 times negative 2 plus c. So that's 4. You take it over, becomes negative 2. Which confirms that now, that to be negative 2. So y is equal to negative 2x minus 2. It's negative 2x minus. Okay. (1.6) for 5 marks, the coordinates of D. If I look at D, D is the point of intersection of AD and BC. We have the equation of AD to be negative 2x minus 2. However, the equation of BC I don't have. So what I'm going to do is I'm going to work out the equation of BC first. The equation of BC, we know it's going to be in the form of y is equal to mx plus c, which is y is equal to half x plus c. We have calculated the gradient already. So I'm going to substitute c, which is 4 and negative 2. That's an x and a y. So negative 2 is equal to half times 4 plus c. So that's going to give you 2. Take 2 over, becomes minus 4. Which now also makes sense that to be minus 4. Okay? So my equation is y is equal to a half x minus 4. Now for B, which is the point of intersection, we say the two graphs are equal to each other. We do simultaneous equations. So therefore, negative 2x minus 2, which is the equation of AD, is equal to a half x minus 4. The x is one side, numbers the other side. So minus 2x minus a half is minus 5 over 2x is equal to negative 2. So it's going to give you negative 4 over negative 5, which is 4 over 5. Okay? or you divide both sides by negative 5 over 2. You can sub this either into the equation of BC or AD. I'm going with AD. So y is equal to negative 2 times 4 over 5 minus 2, which is negative 8 over 5, minus 10 is negative 18 over 5. Therefore D is 4 over 5 and negative 18 over 5. Okay, if you had substituted into the equation of BC, you should get the same solution there. Okay. I'm going to write this in. So D is going to be 4 over 5 and negative 18 over 5. Okay. Any confusion on this one? Yes?
So is there another way to get these answers? Like,
Yeah, if it's analytical methods, yes. So which way do you think you can calculate it?
I don't know.
Okay, you don't know. But there's not only one way of doing it, okay? But if you come with a method, and I can tell you which right or wrong. Okay. 1.7. In 1.7, we are told determine the area of triangle AEC. The area of triangle AEC. So AEC, this triangle, is the same size as this triangle. Why? Because the angles bisect the area of a parallelogram. Okay, so I'm just going to write that down. So area of triangle AEC is equal to the area of triangle ABC. Why do I need to say that? Is because to calculate the area of this triangle is going to be a bit steep. Okay, it's going to be a lot of calculations there, if even possible. Even if I look at this triangle here, I can go with a half base times perpendicular. Can you see that? Even the base BC, I already have. So the area would simply be a half BC times AD. But we know what BC is. BC is the root of 80 or 4 root 5. So we must just calculate AD. So the length of AD is going to be the square root of minus 2 minus 4 over 5 squared plus 2 minus 18 over 5 squared. And let's put that in the calculator. So the square root of negative 2 minus 4 over 5 squared plus 2 plus 18 over 5 squared. It's going to give you 14 root 5 over 5. 14 root 5 over 5. That's 14. Yeah, 14 root 5 over 5. So we'll substitute everything now in that. So area of the triangle is equal to half BC, which is the root of 80 or 4 root 5 times 14 root 5 over 5. Which is simply that answer multiplied by root 80 multiplied by half. Whoops. Answer times root 80 multiplied by 28. I'm sure there's another way of doing it. Again, if you find it, you can bring it to me.
Wait, sir, I do double check.
How do you double check?
Yeah.
How do you mean how you double check?
But remember you...
We're not busy with maths, is it? Yeah?
No.
You must make sense to us.
No, but like, still, like, okay, for example, like, you do like this method.
You know you're asking now more questions since you're in maths, isn't it now? Than what you ever was asked when you were in maths. But okay, ask.
I feel like know that you are right with like this because I don't think
You don't know.
done. You some of the times.
But you see the answer, is the answer negative? No. You see that there you got your perpendicular height and you got your base. Area is half a base times that. What else you want to do?
Like, if you get it wrong, then you.
Otherwise you could have, you could have actually used the area of a parallelogram. The area of a parallelogram is base times perpendicular height. So here you got your base, this is considered as your base, there's your perpendicular height. And because it's half, which is a triangle, you divide that answer by 2, you should get 28 units squared as well. Yes?
I need to go now. Mommy's uncle calls me.
No. Now, is your mama now?
She said she's gonna come now, so
Okay, when she comes, you can go. Okay, so people, we are told here in the diagram, B is a point on the y-axis. A, which is 4 and y, B, C, which is 3 and 0, and D, which is 7 and 6, are vertices of a rectangle, A, B, C, D. Diagonal, BD and AC are drawn. The inclination of DC is alpha and BAC is theta. The question says, first question, determine the gradient of CD. Determine the gradient of CD. So to work out the gradient, I need 2 points, not so, which I do have. So it's y2 minus y1 over x2 minus x1. So it's going to be 6 over 4, which is 3 over 2. This gradient is going to be 3 over 2. Alright. Next question. The question says calculate the size of theta. Now to calculate the size of theta, sorry, alpha in this case, which is this angle here, we know this is going to be acute or obtuse? Acute. So when you do this calculation, you'll see it's acute. If it's not acute, it wouldn't make sense. Okay. When you take your question, when you're confused and stuff like that. Okay. So we got alpha is equal to arctan or shift tan of 3 over 2. And acute angles lies between what? 45.
90 and 0?
0 and 90. So it's 3 over 2, which is 56, 3 degrees. 56, 3 degrees. Okay. Next question. Show that y is equal to 8. Show that y is equal to 8. Okay, so you see where y is lying. Okay, and we know this is 90 degrees here. So we know that the gradient of AD times the gradient of CD is equal to -1. Okay, so the gradient of AD is equal to -1 divided by CD, which is 3 over 2, which is -2 over 3. That gradient is -2 over 3. So if we look here, we actually have 2 points here, which is A and D, provided your y coordinate of A is 1. So we can now say that the gradient of AD is equal to change in y, which is y minus 6, over change in x, which is 4 minus 7, which is also equal to -2 over 3. Okay, so we can drop this. So we're going to calculate the solve for y now. So cross multiply. The 3 times y is 3y. 3 multiplied by -6 is -18. This is going to give you -3. Times -2 is 6. Take that over the equal sign. So 3y is equal to 6 plus 18, which is 24. Divided by 3. So y is equal to 8. Okay. So y is equal to 80. Dan zien we like the solution in. Dan zullen we take this off here, as you can see I need the space. So here, you okay?
No, sir, I got the answer right, but I don't think I got the method right.
Okay. And remember, you can't use 8 in your calculation. You must end off with 8.
Sir, I didn't use a.
Okay, at the end we will check what's going on, otherwise you should be awarded the mark. Okay?
Sir,
Yes?
someone, she can't find the 51.
No, whose fault is that now?
That's
Was she here when we ended up? So I can't help with that.
Exactly.
So when your friends are here next time and then your classmates, and you can ask who took your paper. Okay, the question says calculate theta. In 2.4, calculate theta. So we know that these lines are parallel, not so. So alternate angles are equal. So that's your angle theta. So what happens is, if theta lies here, you check it. Okay. So theta lies there. Not so people. So to calculate theta is going to be that angle there minus 56.3 degrees will give you the angle theta. Can you see that? So to calculate this angle, let's call this beta for now. We need the gradient of AC. So tan of beta is equal to the gradient of AC. What could I call that? ACX, whatever. So the gradient of AC is going to be 8 minus 0 over 4 minus 3. That is tan of beta. So angle beta, of course, is equal to 8 over 1. So arctan of 8. So you shift tan or arctan of 8 gives us 82,87. So therefore your theta angle is going to be 82,87 minus 56,3 degrees. Minus 56.3. You're going to answer 26,57. Okay. Go to question 3. Calculators may not be used in this question. Here we are told that in the diagram below, P, which is K and 24, is a point in the second quadrant such that PO is 25, which is that line there. N is a point on the x-axis. N is a point on the positive x-axis, and PON is theta. First question. Determine the following. K. To calculate K. So what do we do is you conclude the triangle. There's 90. That's an X and a Y. So this is K, and that is 20.
Zara Peterson, can you come to the office, please? Zara
Okay.
Peterson, please report to the office.
So how do we calculate K? By using Pythagoras. So 25 squared is equal to K squared plus 24 squared. We get over the equal sign, so it's 25 squared minus 24 squared is equal to K squared. So K squared is equal to, I think it's 59. 25 squared minus 24 squared gives you 49. Remember, if I introduce square root, what was I not forget? Plus minus. So K is plus minus 7. So which one of the two is it? The positive or the negative? Negative. Because there's a negative side on the x-axis. So therefore K is equal to negative 7. Alright. Look at 3.1.2. The question is to work out tan of theta. Tan of theta. So tan is opposite. So remember, this is now your reference angle. It's going to be your opposite, which is 24. or your adjacent, which is negative 7. Okay. Next question. In 3.1.3 we are told if sine of theta, determine sine of theta if, no, determine sine of alpha if alpha plus theta is 360 degrees. But remember that the diagram gives reference to theta and not alpha. So we must write alpha in terms of theta. So theta, alpha is equal to 360 minus theta. So in other words, sine of alpha, which is sine of 360 minus theta. So we go, the cos diagram, all stations to claim on. So 360 minus theta is in which quadrant? Quadrant 4. Sine positive and negative? Negative. Sine theta. So when I say sine is opposite over hypotenuse, so it's negative 24 over 25. Okay. And then the last question, 3.1.4. They want you to calculate sine squared theta minus sine squared alpha. But alpha is 360 minus theta. So it's sine squared theta minus sine squared 360 minus theta. But what is sine of 360 minus theta? Negative sine theta. But because of the square it remains positive. So it will simply be sine squared theta. Now that positive times negative is negative sine squared theta. And what is sine squared theta minus sine squared theta? 0. Your answer is simply 0. Okay. Or what we could have done was, as I'm just checking now in the memo, what I've done was I said sine squared theta minus sine squared alpha. So sine squared theta, sine is opposite, which is 24 over adjacent, hypotenuse, which is 25. And it must be squared minus. Now sine squared theta, sine theta you have already worked out to be negative 24 over 25. And it must be squared. You see it's the same. The minus between it will cancel and give you an answer 0 in 1. So either or, you should get the full mark. Okay. Let's go to the next question. In question 3.2, we are given that cos of beta is equal to negative a third and beta is greater than 0 but less than 180. Greater than equal to 0 but less than equal to 180. Determine with the aid of a diagram the value of the following. So what does this tell us? This tells us that the cos is negative. My goal. Please take note, yeah? Or did you get the full marks for the section? Full marks? Exactly.
This is for grade 11 only, for the subject is for maths lit and for maths, like the code results analysis, the department wants that. And then I wanted to ask for maths, did you sign the list Mrs. Regan gave me? That was in your pitch. Okay, that was in your pitch.
I just got, yeah. Sorry about that. So, so where's cos negative? Cos is negative in quadrant 2 and 3. But we are told that beta is greater than 0 but less than 180. So it's quadrant 1 and 2. So of course it will be quadrant 2. So that's your angle beta there. And then cos stands for adjacent of hypotenuse. So adjacent is 1, hypotenuse is 3. We know that this negative belongs to the 1. The x part of your, the x is on the negative part of your, or your adjacent on the negative part of your x-axis, is negative 1. So we work out the opposite squared plus negative 1 squared is equal to 3 squared. So you got your opposite side squared is equal to 9 minus 1, which is 8. Okay, negative 1 squared is positive 1, you take it over, it becomes negative. The square root thereof, of course, don't forget plus minus. So your opposite is going to be plus minus 2 root 2. But is this going to be positive or negative? Negative. Positive is your y part, positive y section of the axis. So it's going to be positive 2 root 2. Okay, so the question says determine with the aid of the diagram the value of the following. So 180, there's all stations to Claremont. 180 plus takes you to quadrant 3. You stand positive or negative? Positive. They stand a beta. So tan is opposite, which is 2 root 2 over adjacent, which is negative 1, negative 2 root 2 is the answer they're looking for there. Okay. In 3.2.2, the question says, #90 3 sine beta minus 90, of course we add 360 to that, gives you 3 sine 270 plus beta. The 270 plus beta is in quadrant 4. Sine positive or negative? Negative. So it's negative 3 and sine changes to cos. Okay, cos of beta. So it's negative 3 times. Cos of beta, we are given it in the introduction that cos of beta is negative a third. We can just replace that with negative a third, which gives you an answer of positive 1. Okay. Go to the next question. In 3.3.1, we are given that sine of negative 210 over cos of 300 plus cos of 90 plus x, or x plus 90 is the same thing, plus 360 plus x. Now again, your answers are, we've got all stations to 3.1, that's 0, 90, 180, 270 and 360. So negative 210, we add 360 to it. If I add 360 to negative 210, I get 150. Negative 210 plus 360, I get 150. And which quadrant is 150? The second quadrant, which is 180 minus 30. Over 3 cos 300 is going to be cos, which is in the fourth quadrant, 360 minus 60, plus, as 90 plus theta, so 90 plus x is in your second quadrant. Cos is negative, although it changes to positive. And although it's sine, sorry. And then 360 plus takes you into the first quadrant. All is positive signs. Alright, so sine of 180 minus 30, second quadrant, sine is positive. So it's positive sine 30 over 360 minus cos of 60. That will be minus, that cancel, minus 1. So that takes you to your special triangles there, which is 30, 1, 2, root 3, and 60 of course. So sine of 30 is 1 over 2, cos of 60, leaves you 60, it's your adjacent of hypotenuse, also 1 over 2 minus 1. Half divided by half is 1, and 1 minus 1 of course is 0. Okay. Then for 3.3.2, for which values of x is the given expression undefined for 0 to, where x is greater than 0 or less than or equal to 360. So it's not including 0 here, it's including 360 here, remember? So if we look at, when is something undefined? It's undefined when the denominator is equal to 0. So this denominator here, actually, so it's sine of 360 plus x is equal to 0 in other words. Sine of 360 plus x is equal to 0. That we already worked out to be sine of x. So where sine of x is equal to 0, we take it to the graph. We take it to the sine graph. And that is 1 and minus 1, of course. That is 0, 180, 270. And 360. This, of course, is 270 and 90. So where sine of where sine of x equal to 0? It's equal to 0 at 0, 180 and 360. But remember, they're omitting 0 here. They're taking 0 out of the solutions there. So it's going to be, therefore, x is equal to 180 or x is equal to 360. One of the two will work, will make that expression undefined. 3.4, the question says, without the use of a calculator, you must simplify. So we have cos of 210 times tan of 130 over sine of negative 60 times cos of 420. So cos of 210, so again, let's just draw our cos diagram here. Stasis to play one. That's 0, 90, 180, 270, 360 then. So 210 is in the third quadrant, so it's going to be 180 plus 30 times. Tan is going to be 135 in the second quadrant, so it's tan 180 minus 45. Hi.
I just wanted to come in.
Okay, no problem.
Hi girls. This is our maths department, Mr. Bodin. I'm head of the maths department as well. Yeah, and he's got his own YouTube channel, so he's the best person to speak to if she gets stuck somewhere in the maths area. So, yeah, this is one of many. Okay. Alright. Yeah, maths is. Alright. Thank you. Thank you, sir.
No problem. And that's over. So it's negative 60. So it's either you're going into the fourth quadrant or you add 362. Okay. So it will become sine of 360. If you add 360 to this, I get 300. Which puts you in the fourth quadrant, which is 360 minus 60 anyway. Times, if you subtract 360 from 420, so 420 minus 360 gives you 60 degrees. So that's straight cos of 60. Okay. So 180 plus takes you to the third quadrant. Cos is negative, so it's negative cos 30 times 180 minus 45. Second quadrant, tan is negative. Tan 45. And this is over 360 minus 60. It's going to be negative sine 60 times cos 60. So again, that takes you to your special angles. So it's going to be 31 to root 3. And of course 60 is here on top. So negative, negative, negative. The ultimate answer is going to be negative. So cos of 30, cos is adjacent of hypotenuse, so it's root 3 over 2. Tan of 45, the 45 degree triangle. The isosceles triangle, so it's 1, 1 root 2. So it's going to be 1 over 1. Sine of 60 is opposite, which is root 3 over 2. Cos of 60, of course, is a half. So root 3 over 2 cancels root 3 over 2, and 1 divided by a half is negative. Okay. The next one. Question 4. So here we are told if sine of 41 is equal to m, write the following in terms of m. So sine stands for opposite over hypotenuse. I don't have to draw this on the cos diagram or on the Cartesian plane because this is in the first quadrant anyway. So that's my reference angle there. Sine is opposite, that is O over H. So it's O, which is m, and H is 1. I apply Pythagoras, I get 1 squared is equal to m squared plus your adjacent side squared. So your adjacent side squared is equal to 1 minus m squared, and the square root thereof is it's going to be the square root of 1 minus m squared. Okay, so cos of 41. Cos is adjacent of hypotenuse, so it's the square root of 1 minus m squared. Remember, this angle is 49. Why? Sum of triangles. Okay. The next question, of course, is the tan. You want tan of 49. Tan is your 49 degree angle. Tan is opposite of adjacent. So it's the square root of 1 minus m squared over m. Let's look at the next question. 4.1.3. 4.1.3 is simply going to be cos 200 and it's all stations to Clement, 222 takes you to the third quadrant, so it's going to be cos of 180 plus 41. Cos is negative in that quadrant, so it's negative cos 41. Cos of 41 is adjacent of hypotenuse, so it's negative root 1 minus m squared. I think there's one question left. Dude, let's just wrap these two up and then you guys will go. Sure, you can't wait to get out of here. Yes, I feel the same way. So you got negative 319, so you say negative 319 plus 360, give you an answer of 41 degrees. So this is going to be the same as tan of 41. Remember, if I add or subtract 360 from an angle, I don't change anything. So tan of 41, tan is opposite over adjacent, so it's going to be m over the square root of 1 minus m squared. Okay, and the last question here before we break is of course sine of, let's just pull this down. What's going on now? Did I do this one? Yes. Then they want you to calculate sine of 941. So what we say is 941 minus 360. Minus 360 is 221. So that is the same as sine of. Now 2 to 1 is in quadrant 3, which is 180 plus 41. Not so. Is sign positive or negative in that quadrant? Negative sine 41. So sine is opposite of adjacent, so it's negative m over 1, which is negative. Okay, so in our next lesson we will conclude this paper. People enjoy your holiday. I don't expect you to come to school tomorrow, but if you're here, we'll wrap it up. Okay.